With that, we will begin with a 15-minute presentation from Mr. Knightley with Invenergy.
Good evening, everyone. Can you hear me? Thank you. Did everybody see the board okay? So this is a presentation on Clear River Energy Center being proposed to be constructed in Burrillville. Whoops, sorry. Clear River Energy Center is approximately a 1,000 megawatt combined cycle energy project utilizing advanced technology supplied by General Electric. It's the latest, what they call H-class combustion turbine. It would be the most efficient project in New England, if not in the U.S. The project consists of two single shaft configurations, 2 units. Each of them are air-cooled. The project, being air-cooled, does not use cooling water for cooling the unit. Water makeup is used in the steam cycle. And it has dual fuel capability, meaning it can burn oil or natural gas. And oil is only used in the event that natural gas is unavailable, and we anticipate that that will be a very limited amount of time, like during the polar vortex, for example, in 2014. Our estimate at that time, it probably would have had about 3 or 4 days of operating on oil in that event. The planned commercial operation for the units are segregated into Unit 1. We're currently looking at trying to achieve commercial operations June 1, 2021 for Unit 1 and June 1, 2022 for Unit 2. The water supply for the facility will be trucked in from the town of Johnston, where we have a facility that will load up the tanker trucks. And the plant configuration was modified from its original proposal to reduce the water demand such that trucking was a potential option. What we did in that instance was really to modify the demineralized water treatment system to eliminate the reverse osmosis system and go with an ion exchange mobile treatment system. Pardon me. And we recycled the steam water, wastewater to be reused. This actually resulted in a significant reduction in the water consumption that we had previously had from something that was over 100,000 gallons a day to approximately 15,000 gallons a day. As I said, the site location, in Burrillville has both adjacent high voltage transmission lines and high pressure gas. The configuration of the project, which I'm sure many of you are familiar with, you have the 2 trains located here. These are the air-cooled condensers. This building is the power block. This is the heat recovery steam generator that generates the steam, taking the waste heat from the combustion turbine, using it to generate steam, to put it into the steam turbine, to in turn produce power. It is the most efficient way to produce electric power using a fossil fuel. The other buildings on the site here, this is the administration building. This is a maintenance warehouse and also water treatment. These are water tanks for raw water, wastewater, and demineralized water. This is the oil storage tank, and this is the gas yard, which has some gas compressors, and then this feature over here is the stormwater. The site location, as indicated, is in Burrillville. It's located adjacent to the Burrillville compressor station, so it's approximately 2,000 feet off the main road, being located directly adjacent to the compressor station. That has access to the high-pressure gas line right here. The Algonquin pipeline is a 2 pipelines, a 30-inch and 24-inch high-pressure system that provides gas up from New Jersey. And then it's hard to see with the lighting here, but right in this location is the National Grid high-voltage transmission line right-of-way, which the project will be utilizing a portion of that right-of-way to connect into the Sherman Road substation. We envisioned that the project had a number of benefits associated with it. We believe that the project will be able to help address the region's energy needs. It will produce reliable, highly efficient energy, and we believe that will promote economic growth within Rhode Island. Actually, we believe that the project would help reduce air emissions in the region due to its efficiency. Help support the integration of renewables, help create local jobs, both for construction and during operations, and create millions in revenue in taxes through a pilot agreement that we have with the town of Burrillville. You know, the need for the project, I know it's something that is people have a concern about. ISO New England has indicated that there is a need for the project and has awarded the first unit with forward capacity auction, capacity supply obligation. But the ISO has indicated, in various reports that have been issued throughout the past several years, that there's a fair portion of the amount of existing generation that has either already announced retirement or is at risk of retiring in the near future. And adding these two things up totals around 10,000 megawatts, which is roughly about a third of the generating capacity in New England. The renewable support that I mentioned earlier, comes from the fact that the project has a fast start capability, has a high ramp rate capability, and these are capabilities that the ISO needs to have as we incorporate more renewables. And the reason for that is renewables are highly variable and they are intermittent. And so, as you add these renewables, they have the potential to create fairly high swings in the generation capacity that's available, and since generation has to match the load, you need something that can fill in the gaps, and that's why additional high ramp rate, fast start capability machines are required. So the first bullet here is speaking, pretty much what I was just talking about, being able to support the renewables. The next line item is talking about the emissions reductions. We had done an analysis that we had provided to both the FSB and the Office of Energy Resources, indicating that adding a unit like this due to its efficiency would actually reduce emissions because it's actually going to displace other older, more polluting plants. And in doing so, actually reduce emissions in the process. And although the 0.89% number here for carbon emissions, CO2 emissions, it doesn't look like a very large number, but that is the emissions throughout the New York, New England region. Because these two regions are electrically interconnected, there is an interface there that we really need to take into account. And that represents roughly about 600,000 tons per year of CO2 reduction. We also envision that there will be some ratepayer savings, and these come about from two factors. One is due to the efficiency of the project, that it's able to produce more power using less gas. It can do so in a more cost-effective manner and allows the project to bid in its energy at a very competitive price, a low price, and that helps drive down energy costs to ratepayers. The second way that it comes about is that by participating in the capacity auction, putting that capacity into the auction helped drive the auction price down, and that also created ratepayer savings. The analysis that we provided was provided to the Energy Facility Siting Board and the Office of Energy Resources, who are reviewing those analyses. Project water supplies indicated previously we had modified the plant system in order to reduce the water demand by the project, thus allowing water to be transported by truck to the facility. We do have a facility, an existing facility in the town of Johnston that we have under option that would be used to house the trucks and fill them from existing infrastructure. And the trucks that we're contemplating on using are roughly 8,000 gallon tanker trucks. And the facility, what we also did was increase the water storage capability of the on-site tanks. So we roughly have 2.8 billion gallons of water storage. We need to hold some of that water in reserve for fire protection purposes, and that leaves roughly 2.2 million gallons for use in the project. Our on-site water demand for the project is approximately 15,800 gallons per day on average. That's the average ambient temperature on natural gas. In the summer, that number goes up a little bit to around 18,000 gallons per day. And in the unlikely event that we have to fire oil, the water demand will go up significantly, and at that point, we would be drawing off of the on-site storage tanks to provide oil and water, which has to be injected simultaneously, and the unit can operate for about 3 days in that mode, and after that, you will run out of oil and run out of water, and so then you would have to go through a replenishment. And in terms of the number of water trucks, that would add about 11 additional trucks for a total of 13. All those, that whole scenario that I just outlined was included in the water plan that we filed with the board back in January of 2017. We also have a contingent water supply, and that's through the trucking company itself, and that is Ben Water Transport, and Ben Water has a long-term agreement with the city of Fall River. We had an additional contingent backup supply with a contract with the Narragansett Indians using a well that they are proposing to put on their settlement systems. The details of that, the impact that that would have is also provided in a report that we provided to the Energy Facility Siting Board in, I believe it was in October. As I said, the project is undergoing a comprehensive environmental review by both RIDEM and the Energy Facility Siting Board. The project will meet the Burrillville noise ordinance, the broadband noise limit that the ordinance requires. The project has filed an air emissions application with RIDEM that we understand is currently under review. And the project has filed a wetland permit applications with both RIDEM and the Army Corps. That was a joint application that we did with National Grid because it covered both the power plant and the electric transmission. And the water supply plan, as I said, we submitted a plan back in January. We amended it in, I believe it was either September or October, and that is currently under review. As I indicated earlier, the project will create, jobs both temporary in terms of construction and permanent long-term jobs with the operating staff. These jobs, the permanent staff, has the potential to inject, about $3.5 million annually into the local Rhode Island economy. And the tax revenue that I indicated would be through the pilot agreement that we have with the town of Burrillville. The interconnections, as I talked about, the water is going to be delivered by truck. The wastewater has been reduced through the modifications that we've made to the facility, and that would be hauled off-site for treatment at a qualified facility. The electricity connection and the gas connection is through the adjacent utilities that are there. This is a depiction of the electric transmission line connection. There'll be a new right-of-way across Spectra property, and then the expansion of not the expansion, but the use of the existing right-of-way that National Grid owns, and that is subject to a separate proceeding that has been filed with the Energy Facility Siting Board. That's it.